Welcome to Math with Professor V. In this video, we're going to go over division of polynomials and talk about polynomial long division. So to start our discussion, we have to look at the most basic scenario, and that's when you have a monomial divided by another monomial, meaning you just have one term divided by another term, both of which meet the criteria for being a monomial. And this is done simply by using the rules of exponents. In fact, you probably don't even think of this as division, even though it technically is. You just probably most likely think of, oh, I'm going to reduce or simplify. So all you do is you would reduce or divide the constants. 15 divided by 3, that's 5. And then using our laws of exponents, you subtract top exponent minus bottom exponent. X to the 6th over x to the 4th simplifies to x squared. And then y squared over y simplifies to y to the 1st. And technically this was a division problem, okay? Now, what if we have more than one term in the numerator, but still just one term in the denominator? Well, the process is as follows. You take each of the terms in the numerator and you divide them by the divisor separately. So you would write this as a divided by c plus b divided by c. What do I mean? I have an example right here for you. So let's divide the following. This does not require long division because notice we have a monomial as the divisor in the denominator. So I could just simply rewrite this as 50x to the 4th over 10x cubed minus 30x cubed over 10x cubed plus 20x over 10x cubed, and then simplify each of the terms just like we did up here. Okay, so let's see what we're going to get now. 50 divided by 10, that'll cancel to 5, and then we have x to the 1st, x to the 4th over x cubed, minus, the next term's just going to be 3 because x cubed cancels out. And then lastly, this is akin to having a remainder. So 20 divided by 10, yes, that will simplify to 2, so plus 2. However, we have a higher power of x in the denominator. So I can cancel the x in the numerator, but I have, that's right, an x squared in the denominator here. Okay. So that's how we divide polynomial by monomial. Polynomial by monomial. But I'm sure what most of you are all here for is what do we do when the divisor is not a monomial? If it has more than one term, maybe 3, what do we do? Well, then we have to use polynomial long division. And it might have been a hot minute since you've done long division. So let's go through the process with just like a little warm-up example, not with polynomials. And I just want you to remember there's 4 steps when you do long division. We first divide. You're like, no, duh, we're doing long division. I'll show you what I mean though. Then you multiply. Then you subtract. And then you bring down the next term. And then you repeat until you can't divide anymore. And I'll clue you in on how that's done. And then you go back to the beginning. So the 4 steps are divide, multiply, subtract, bring down. All right, so let's just see how this works again. We have 14 divided into 389. I'm not going to look at all of 389. I'm just focusing on 14 divided into 38. So 14 goes into 38 twice. That's step 1. Then step 2, I multiply. I multiply 14 by 2, and I list that underneath. So 14 times 2, that's 28. Now it's time for step 3, we subtract. So 38 minus 28, that's 10. And then last step 4, I bring down the 9. Okay. Then you repeat the process. So 14, does 14 go into 109? Yes. How many times? 7. So 14 times 7, now I'm on step 2, I multiply. 14 times 7 is 98. I list that here. Step 3, I subtract. And there's nothing else to bring down. nor does 14 go into 11. So this is my remainder. So our final answer is 27, that's my quotient, plus 11 divided by 14. 27 plus 11 divided by 14. We don't normally write it that way though, right? We write it 27 and 11/14, which is kind of odd, but it is what it is. So 27, if you want to put remainder 11 up here, sometimes people do it that way. Just check how your instructions want the final answer. That's really the key. Okay. Good, good, good. Just to get some notation under control. So the stuff that you're dividing into underneath the division sign, this is the dividend. The thing that's doing the dividing, this is your divisor. Up top here, this is our quotient. And then you already know where the remainder is. Okay, good. I don't think it's, too crucial that you use the terms dividend and divisor, but just so you hear them, you don't get freaked out and you know what quotient is. That's probably more important. Okay, so now let's work on applying this 4-step process to polynomial division. And when you do step 1, right, there's 4 steps. When you do step 1 to divide, you're not looking at the entire polynomial. You're just looking at what's in the front. So you're only paying attention to 12y squared and 2y. Nobody else matters. So step 1, you divide, and you're going to divide 12y squared by 2y, which gives us 6y. The other way to think about it, you don't have to write anything out. You just go, what do I multiply 2y by to make it 12y squared? Why 6y? That's it. Okay, that's step 1. Then do you remember what step 2 is? Good, you multiply. So this time you multiply what you just wrote up top by the entire divisor. So you got to distribute, and I'm going to write the result underneath right here. So this is 12y squared plus 6y. Yes, I'm distributing. Here it is. Okay, step 3, you subtract. You subtract that new yellow row from the row up above. Okay. The entry on the furthest left should cancel out. If it doesn't, something went wrong, okay? That should cancel out always, the one on the furthest left. Then here's where things can get a little dangerous. This minus sign has to distribute to everything in these parentheses. So this is 20y minus 6y, which gives me 14y. Now, if you're sitting there going, oh my goodness, Professor V, I'm going to forget that for sure. I am careless with the negatives. They always get me. Then that's fine. I have a solution for you. What you're going to do instead is not put parentheses, and you're just going to switch the signs of everything in the row that you're subtracting. So you're going to just distribute the negative through. Okay? I don't like to do it all the time because I think it looks ugly. I do. But if you know that that's going to be a dangerous moment for you, then, be proactive. Distribute that negative. All right. Now, step 4, bring down the next term. Bring down the 7, so plus 7. And then we repeat the process. So you're just paying attention to 14y and 2y. Don't look at anybody else, okay? So step 1, we divide. This time I'm only looking at 14y and 2y. So 14y divided by 2y is 7. Again, alternatively, you could think to yourself, well, what do I multiply 2y by to make it 14y? And that goes up here. So put plus 7. Then we're on to step 2. We multiply. So I'm going to distribute this 7 through. So 7 times 2y, that's 14y, plus 7 times 1, 7. Beautiful. Look at this. Everything canceled out. So what does that mean for us? When I subtract now, I have just 0. So my remainder is actually 0, and there's nothing to bring down. So the problem is done. So my quotient, can you identify it, It's 6y plus 7. And since we have 0 remainder, that means I actually have 2 factors of the dividend. So you could actually say, oh, I know that 6y plus 7 times 2y plus 1 gives me 12y squared plus 20y plus 7. And if you're nervous that you did it correctly, then you could just always FOIL it back out and make sure. Because we had 0 remainder in this case. How lovely, yes? Okay, let's look at another example. I don't expect you to have mastered it after one example. And here we go. I'm not going to write the steps 1 through 4 anymore. I'm just going to hop to it. So we have r minus 3. That's my divisor, whatever's in the denominator. And that's getting divided into 2r cubed minus 5r squared minus 6r plus 15. Very good. So again, to start, you only look at the leading terms. Don't look at everything. It'll just give you a headache. What do you multiply r by to make it 2r cubed? 2r squared. Very good. Step 2, you multiply. You multiply the 2r squared by the entire divisor and you write it underneath here. So this is going to be 2r cubed minus 6r squared. Good? Now I subtract this row from the row above. The furthest left entry cancels out just as I expected it to. And then remember, this is now plus 6r squared when I distribute the negative. And negative 5r squared gives me positive 1r squared. So that's step 3, subtract. Step 4, bring down the next term, minus 6r. Good? Okay, then we repeat the process. So I'm going to divide step 1, divide r squared by r. Also just think to yourself, what do I multiply r by to make it r squared? Just r, positive 1r, so put that up top. Step 2, you multiply. You multiply r by r minus 3. Write the result here. So r times r minus 3, r squared minus 3r. Step 3, subtract. So this r squared cancels. Perfect. I have negative 6r plus 3r, which is negative 3r. And then step 4, bring down, plus 15. Can I keep going? Yes. You're done when the degree of what's here is lower than the degree of your divisor. This is degree 1 because we have r to the first, and my divisor is also degree 1. So we can keep going. We're not done. In fact, you might say, yes, of course, Professor V. It's very clear to me. Negative 3r divided by r is just negative 3. What do you multiply r by to make it negative 3r? Negative 3. So that goes up top. Then that negative 3 distributes to the divisor. So negative 3r plus 9 is what I have. Now step 3, we subtract this from the row up above. This canceled out. Perfect. And then this is now 15 minus 9. 15 minus 9 is positive 6. There's nothing to bring down, and I can't keep dividing because here we have r to the first. There's no r's here. This is degree 0. This is my remainder. So we have a remainder this time. Okay, so you could write remainder 6, but a more finalized version of putting your answer is very similar to how you write your fractions when there's a remainder from doing long division. So you would write the quotient 2r squared plus r minus 3 plus you put the remainder over the divisor like that. And that's your final answer. Okay, how are we doing? Good? All right, I have a few more. They will get increasingly difficult so that by the end, you are a professional. That's the goal, right? Here we go. Example C, x cubed plus 4 minus x divided by x plus 2. So a couple funky things are going on here. First of all, this is not in descending powers, descending order. So we have to fix that. There's also an x squared missing, so we need a placeholder. So I'm putting x plus 2 out here. And then we have x cubed. Now you can just leave a blank spot where x squared goes. I was taught to put 0x squared, so that's what I do. But if you just want to leave a space and that's not going to mess you up, you go for it, okay? You live your life. Then minus x, then plus 4. All right, step 1, divide. So divide x into x cubed. That's x squared. Step 2, multiply. So distribute that through. That's going to be x cubed plus 2x squared. Step 3, we subtract. So x cubed minus x cubed, yep, that cancels. 0x squared minus 2x squared is negative 2x squared. And then step 4, bring down. So I'm bringing down negative x. Okay, now repeat the process. So divide negative 2x squared by x. What do you multiply x by to make it negative 2x squared? Yes, negative 2x. Good job. Then we multiply. So negative 2x distributes through to the divisor. So that's going to be negative 2x squared minus 4x. Step 3, we subtract. So this cancels out. And then this is negative x plus 4x, which is positive 3x. Fantastic. And then step 4, bring down, plus 4. This should be the last time. So now we're dividing 3x by x. Plus 3 goes up top. Now that distributes through to the divisor. Multiply, step 2. That's 3x plus 6. Step 3, subtract. 3x cancels. 4 minus 6, negative 2. I can't divide anymore. This is degree 0. Divisor is degree 1. So we're done. That's my remainder. So you should write your final answer as quotient, x squared minus 2x plus 3, plus remainder divided by divisor. So since it's a negative 2, I'm going to put minus 2 over x plus 2. How's that? Good. Let's box it. Beautiful. What a lovely little answer. Okay. One more pretty similar. I want you guys to try this one on your own. That way you can see if you've got a hang of it. You know, it's all fun and games when you're watching me, but then when you have to do it by your lonesome, it's a whole nother story. I know. So pause the video. Do yourself that favor. Okay, did you do it? Did you get remainder 30? Yeah? Okay, let's see. So x minus 2, we're dividing that into 3x cubed minus 2x squared plus 5x plus 4. Here, I'll color code. So divide 3x cubed by x. What do you multiply x by to make it 3x cubed? 3x squared. Beautiful. Then you multiply. So that distributes to the divisor. That's going to be 3x cubed minus 6x squared. Step 3, subtract. This cancels. And then this is negative 2x squared plus 6x squared. That gives me 4x squared. And then step 4, bring down, plus 5x. Then we repeat. Okay, so divide 4x squared by x. It's plus 4x. Then we distribute. Boom, boom. So that's going to be 4x squared minus 8x. Step 3, subtract. This cancels. 5x minus negative 8x, so we're adding. So 13x, and then bring down, so plus 4. Keep it going. Oh yeah, 13x divided by x. 13, very good. Plus 13. Step 2, multiply. So I'm distributing 13 to x minus 2. So it's 13x minus 26. Step 3, subtract. These cancel. Negative 4, that'll be plus 26. I get 30. That's my remainder, right? I can't divide now. That degree is higher than what I have here. Okay, so our final answer is quotient 3x squared plus 4x plus 13 plus remainder over divisor, 30 over x minus 2. How are you guys doing? I actually, believe it or not, I have 2 more, but I think now that you guys are becoming so professional, it won't be such an issue. Here's something we haven't done yet. Don't be frightened. The divisor is degree 2, x squared. You can handle it. Let me zoom out a little. That was like, okay, perfect. So it's no big deal. This is one of the fabulous things about polynomial long division is, you know, the divisor can really be any old polynomial, even degree 2, 3, 4, you name it. Oh yeah. So here we go. We have x squared minus 2x plus 50 out here. That's my divisor. And then the dividend, x cubed plus x squared plus 44x plus 145. No panic attacks. This process will be no different than what we've been doing. You've just got a little extra little term going on here, but it's not a big deal, okay? Don't fret. Still just look at the leading terms. What do you multiply x squared by to make it x cubed? X, very good. Then step 2, you multiply. You multiply that x by the entire divisor listed under here like normal. So x cubed minus 2x squared plus 50x. Are we okay? Look at you, you're fine. Okay, now subtract, step 3. These go bye-bye. Then just be careful. X squared minus negative 2x squared. So that's going to be plus 2x squared. So we've got 3x squared. 44x minus 50x, that is negative 6x. So subtraction is done. Now step 4, bring down. Repeat. Divide 3x squared by x squared. What do you multiply x squared by to make it 3x squared? Good, plus 3. That goes up top. Then you multiply, so distribute that through. Here we go. 3x squared minus 6x plus 150. Now step 3, subtract. This cancels. This also cancels. Oh, we were so close to no remainder, but we have one. 145 minus 150 is negative 5. That's my remainder. I always get excited when there's no remainder. It's a little more satisfying. Okay, so here we go. Final answer. I would write it as x plus 3 minus 5 over the divisor, x squared minus 2x plus 50. Okay, okay. Last one. Last one. I think you guys can do this one on your own. Or at least give it a go. Give it the old college try. Would you? I'm going to just warn you before you attempt it. You're going to need a placeholder in the divisor. Oh yeah, that's a thing too. So sometimes you need a placeholder here. No, we're good. Nothing's missing. But we need a placeholder here because there's no x. So either put a space or put 0x. Okay, did you do it? I hope you did. X squared plus 0x plus 9. I think this might be my favorite one we're going to do today together. 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. Don't be scared that it's long, you know. You'll survive. You'll see the end of this problem. Unlike some mathematicians, they dedicate their whole lives to working on proving some theorem or whatnot, and then, you know, they die before it's done. You're going to see the end of this, and you'll be victorious. So here we go. 3x to the 4th divided by x squared. So what do you multiply x squared by to make it 3x to the 4th? 3x squared. Then you distribute. Boom, boom, boom. So you're going to have 3x to the 4th plus, this is a little weird, but you do it, 0x cubed, or just put a space, plus 27x squared. So step 2 is done. Step 3, subtract. So 3x to the 4th cancels. This is going to be now 5x cubed minus 2x squared. Did you remember the minus? Oh, good. And then bring down the next term, 45x. Okay, repeat. So now I'm going to divide 5x cubed by x squared. So x squared times 5x gives me 5x cubed. Good. Then distribute. Write the result here. So that's 5x cubed plus 0x squared plus 45x. Step 3, subtract. Ooh, bonus. This cancels, so does the 45x. So what do? Don't freak out. You have negative 2x squared. I'd still put plus 0x, so you have that placeholder there. Or just leave a nice space for it. And then bring down, that's the last term. This should be the last round. So negative 2x squared divided by x squared is negative 2. Then we distribute. Okay. So then this is negative 2x squared plus 0x minus 18. Subtract. Finally, look at this. Are you excited? 0 remainder, my favorite. Boom. Great. So the quotient is 3x squared plus 5x minus 2. And actually, what this means for us is that 3x squared plus 5x minus 2 times x squared plus 9 gives us back the dividend. Who's the dividend? This guy. So if you were to sit there and multiply all that out, you should get 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. Okay, so that concludes this video on polynomial long division. Now, very shortly, I will be releasing a video on synthetic division, which basically is a faster way of dividing polynomials, but you can't always use it. You can't use it in this particular problem because our divisor was degree 2. So stay tuned, make sure you're subscribed and you have your notifications on, because when I release the synthetic division video, I'll redo some of the problems that we did in this video where it applies. So the ones that you can do synthetic division on, for example, are D, C, and I'll work through some more and show you the process in case you don't know it. Also, you know, different countries, different schools have different ways of teaching it. I'll show you my way. You probably, if you've seen it already, might have a different method, but it's all good. It's faster, it's cleaner. However, it's not always the way to go. So that's why we still need to know our polynomial long division. That concludes the video. Don't forget to give it a thumbs up. And if you need help with any other topics in your math classes, I have all my videos organized into playlists here. So you can just go through. I have Calculus 1 video lectures, Calc 2, Calc 3, full length and short videos. And just use the little search bar too on my channel to see if I have a video on a topic that you're looking for. I have almost 1,000 videos now, so I probably do. I probably do. And you can also follow me on Instagram, TikTok, Math with Professor V. I'll be back sooner than later, guys. I love you all so much. Bye.